Hi there, awesome people. By your requests, I'm revisiting this series to show you just how easy it is to integrate a different storage solution into our app. This time, we'll implement a permanent data storage solution using the new and shiny SwiftData. Of course, that will still stick to our current repository design pattern right here and try to adhere to it, even though SwiftData is strongly coupled with the view. In general, I'd advise not to fight against the framework, but since I'm a bit stubborn and value testability and clean architecture, I'm going to push the limits just a bit. Okay, so first of all, let's make some modifications to the folder structure. So what I want to do is move this journal entry model to our base shared folder under features. This is because this model is used across our app, so it makes sense to put it in a model folder under base shared. So let's just create a new folder, call it models, and just drag this journal entry under the model. And there we have it. And also let's collapse the views folder, the components, utilities. Basically, we're gonna work only on this model file here in the repositories and in our view model. And that's why I valued a good architecture from the start, because we don't need to make any modifications in the view. The view doesn't have to know about the logic behind it. So the only modifications that are gonna be here in the home view model. We're gonna inject a different repository. It's gonna be permanent save repository. And then we're gonna actually implement that repository under the base shared repository folder. So first of all, let's update our model. This is journal entry. We need to remove this default UID string and create a custom initializer, just like that. And of course, we can specify a default value right here, hit Ctrl M, and there we have it. Now, this is a struct that we're using across our app, basically to manipulate our data. But this is a struct. SwiftData uses a class for the model. So we can't use this struct in order to save a permanent journal entry. So for that, we're gonna make another model. First off, we're gonna import SwiftData. Then below this, we're gonna say add model, the model macro, say class journal entry local model. You're gonna use all these attributes. Gonna make them var, and for the ID we're gonna use a macro called attribute dot unique, and also gonna create an initializer. Same as above, hit Ctrl M, and we should be all good. Now let me explain it again. We're gonna use this journal entry in our view model because a struct is faster, is more reliable, is more efficient. We're gonna use it to populate our UI and modify it. But this local model is going to be used only at the repository level. We're going to map this journal entry to a journal entry local model, and then that object that is created from this class is going to be saved in our local DB. And the same thing when we fetch. We're going to fetch a journal entry local model, and when we pass data from the repository to the view model, we're going to pass a journal entry. So we're going to make this mapping between these two data structure types. I know it sounds complicated right now, but just stay with me. It's gonna be a lot more clear in a couple of minutes. Okay, now let's go ahead and create the new repository. Hit new empty file, call it local journal entry repository. Let's import SwiftData. Also, if we check out this in-memory journal entries repository, we can see that it is an actor and it implements this protocol. And all these functions are gonna be auto-completed for us. So let's just do that. Go back to our local journal entry repository, create an actor, call it local journal entry repository. It implements the journal entries repository. I'm gonna complain in a second. Just hit fix here. I'm gonna have all these functions right here. Just add a dummy return in order to avoid the complaining from the compiler. Add here import foundation, and also here return an empty array for now. And there we have it. We have a repository that is meant to save our data locally. But because we're gonna use SwiftData, we have to do a little bit more work. And we're gonna start with a new macro called model actor. As per documentation, it converts a Swift actor into a model actor, and it generates some boilerplate code for us that fulfills some requirements. Now let's start with this create function. And first of all, we have to map this journal entry to a journal entry local model. So let's type let local journal entry equals to journal entry local model. And for the ID, we're gonna use the ID from this journal entry, and so on and so forth. Again, put your cursor here, hit Ctrl M. It will make it pretty for us. Now, since we have this model, we can insert it in our local DB model context. And you might wonder, where is this model context from? Well, it's from this model actor. So model context.insert local journal entry. Now, after we inserted this model into our context, we have to save it. So do try model context.save. And for catch, you're gonna throw a dot save failed. That was really simple. We have a create function that I'm pretty sure that it works, but let's continue with implementing this retrieve all, and then we're gonna be able to test a create and a fetch. Now let's start implementing this retrieve all. I'm gonna start by saying a do catch throw dot fetch failed. We're gonna fetch a journal entries local model from our DB. So let journal entries local equals try model container this time dot main context dot fetch, and as a fetch descriptor for journal entry local model. Now it complains because we use main context here that is associated with the main thread, so we have to add here the main actor macro. There we go. Now we have to return something, but this function returns a journal entry, which is a struct, but we just fetch the journal entry local model. So again, we have to map it from this type to this type. So let's just do that. Our journal entries, type journal entries is empty. Then let's iterate over this array. Let's use a higher order function. Let's use a map and create a journal entry data. Hit Ctrl M. For the ID, you're gonna use $0.0.id. For the date, $0.0.postdate, and so on and so forth. And at the end of this map, we can return journal entries. And there we have it. We have a create and we have a retrieve. At this moment in time, we are able to test our main functionality. We can create some journal entries, close the app, like quit it, force quit it, whatever you want to call it. And when you reopen the app, you should still see those journal entries that you just saved. If we are able to see them, that means our implementation works okay and we are good to go. So for this, we have to go to our home view model. Here, instead of injecting the in-memory repository, we have to inject our local journal entry repository. But surprise, surprise, we need a model container. And why is that? It's because, again, we added this model actor that under the hood, it already has an initializer and we have to respect it. Otherwise, it won't compile. So this will be an easy fix. Under repository folder, under base shared, you're gonna create a new subfolder called database. And for this, we're gonna create a custom model container. So new empty file, let's call it custom model container. Let's create a final class. Call it custom model container, and let's create a static variable container type model container, and for that we're gonna have to import SwiftData equals, let's make a do the catch. Here we're gonna throw a failed create a DB or whatever error you want to be. Usually we shouldn't end up in this fatal error case. And in the do, let's create a schema, and the schema is gonna contain our journal entry local model. And as you see, it's an array, so if your app has multiple models in your local database, you should add them here. Now, the only thing that we have to do, just return try model container for schema, and for configuration, let's leave it empty. For our use case, this is enough. But of course, this model container can be customized, can be used only for in-memory, for testing purposes. There's a lot of documentation that you can go ahead and check it out. But for the simplicity of this tutorial, this is really enough for us. Let's go ahead and fix that view model error. Right here, you should be able to use our custom model container.container. Awesome, good job. Now, as I said, we can actually test this application, but we can't do that in our previews. We have to run this app in our simulator. So just hit run because we used a new repository that is using our local DB that is a permanent database. We don't have any entries saved yet. So let's create a new entry. Hit X and we have a new entry. But the real question is, does this stay here like it's permanent, or it will be deleted as soon as we close the app? So if we just force quit the app and just start it again, success. We really managed to integrate a permanent storage solution. This is really awesome. It was simple, it was really fast. We respected our design pattern and we made a scalable app. And I'm so glad we did that because, as you've seen, a design pattern is really important when modifications come in the long term for an app. Now let's continue with the delete function. It's going to be really simple. I'm going to use a do, a catch, I'm going to throw .delete failed. And for the do, we're going to use the model context.delete model where. For the persistent model, you guessed, journal entry local model.self, and for the where, we're gonna use special macro predicate where $0.ID equals ID. And there you have it. The only thing that's left for us to do is to save the context. Try model context.save. Now the same way we tested these functions, let's test this delete function too. Let's run the app again. We have that one journal entry, long tap on this cell, hit delete, and the UI updated, but let's be really sure that this database change really happened. So hit run again, and there we go. The delete worked like a charm. Next up, we have the update function. The update is a little bit more complicated because first of all, we have to fetch a specific journal entry, check if it needs to be updated, and only then save it. So the steps are fetch based on ID, only one journal entry. Step 2, check if it needs to be updated. And step 3, if step 2 is valid, then save it. Let's start with the first step, but instead of placing the code that is necessary for us to fetch a specific journal entry, let's move this step in a separate function right here above, but we're not going to use this retrieve function. And as far as I know, we don't ever use it in our app, but it's there for you in case you need it. But for our case, we need to fetch a journal local entry. We don't want to fetch a struct type. We need to fetch a class type. So for that, we're going to create a private function right beneath this retrieve function. Let's just call it private function retrieve local model or ID string. And this one is going to be the same, except the return type is going to be journal local model. Now we're going to start with a predicate. So let predicate equals predicate type journal entry local model of type journal entry local model. And we're going to filter based on the ID because that is unique. Next up, let's declare our descriptor. So var descriptor equals fetch descriptor with predicate, the one that we just created. And really important to optimize the memory when we fetch this, we can say descriptor.fetchLimit equals 1 because we are after fetching just one model, not all of them, and then just ask for the first from that array. This fetch limit allows us to be more efficient. So after that, let's do a do catch block. Let's throw fetch failed, and here let's type let journal local model equals try model container dot main context dot fetch descriptor and dot first. Let's return it, and in case didn't find one, we just have to throw repository error dot fetch failed. It complains because we need to make this main actor because we use the main context. And there we have it. Now we can use this retrieve local model function in our update function. So step 1 is done. We have to go to step 2. So let's do a do catch block here again. On the catch throw dot update failed. On the do, let's start with the first step, fetched local journal equals try wait self dot retrieve local model or ID. Now we're gonna have two conditions when an update should happen. And to see those two conditions, we can go and access this in-memory repository that we created. And we can just copy the logic from here. Copy this entire if block, go back, paste it here. It's gonna be a bit different. And let's test it again. Test 4 and day rating 2. Hit X. Both fields updated this time. Let's update just only one field. Test 1, leave this 2 untouched. Hit X, and only the test 1 changed. Awesome, good job so far. Because this is the end, so I'm really glad that we managed to reach this point in our app. I was also really happy that some of you requested this video. That means that you follow me and you support me, and that means a lot. So thank you for doing that again. And until next time, happy scribbling.